very simplistic point of view, you are trying to ask business what kind of analytical queries they are going to run. Okay, it is based on their input, it is based on the kind of analytical queries they're going to run that you're going to go back and design your data warehouse. Okay, and this is where we introduce you to the terms of facts and dimensions. Facts are also called measures. So facts are also called measures and dimensions. These are the two groups of tables that you have to identify in dimensional modeling. Okay, what are facts? Any number is a fact. Any number. Think of any number that you can add, subtract, multiply, divide. You can perform any kind of mathematical operation on any particular number. That is what we call a fact. Okay, a typical example of a fact would be something like a sales amount. Okay, so I have a few things listed up here. You can see typical example of a fact can be a sales amount, a tax amount. If you're running a call center business, probably you might want to track okay, how many calls did I make? If you're doing project management, you want to track the number of defects in your project. So these are all facts. These are all things that you can add over a period of time. If you can do all sorts of mathematical operations on the data. In short, facts are things, facts are numbers that um, you can aggregate over something. Okay, that something is called a dimension, which I'll come to later, but facts are numbers which you can aggregate over something. Okay, so if you think about it, zip code and telephone number, maybe I can add one more value here which is called a phone number. If you think about it, they are also numbers, right? Phone number is actually a number. Even if you leave aside a special character that is a number, then phone number is not a fact. You will not go back and add phone number. Phone number is something that you will typically not aggregate across multiple dimensions. Okay, so that's what a fact is. Okay, that's the very first step in doing dimensional modeling is for you to sit with your business, sit with your clients, and try to understand your facts. Facts are things you want to measure. Facts, they are the things that business wants information on. Okay, so if the business is more interested in knowing what was my sales over the past 10 years from this region, from here, whatever. From part goes later, but what were my total sales? The moment he asks what were my total sales, that fact is basically your sales. You have to ask a series of pointed questions to your business, and based on that, you have to figure out what are those metrics that business wants to measure. Okay, so that is what we call a fact. Dimension, on the other hand, is something that adds context to a fact. Okay, now just stay with me here. Dimension is something that adds context to a fact, and the reason why I say this is because, and this is something that I have listed out here, beautiful pivot table that I have got here. Okay, so if you see here, what I've done here is basically, I'll go ahead and remove some of this stuff here for the time being. Let me go ahead and remove this due date. Go ahead and remove the due date. Give me a second here. Go ahead and remove these values here. So what you have here is a single aggregated sales amount, right? This is all you have at this stage. All you have at this stage is a single aggregated sales amount value, right? So you have built your data warehouse, you've modeled your data warehouse on the schema of your data warehouse, and you've come to a point where you're saying that, okay, so sales amount is a measure. Sales amount is something that I want to measure, and that is something that the business is really interested in. Okay, but then if you just take sales amount in itself conveys nothing. It conveys no information at all. All it conveys to you is an aggregate grand total of what is my sales amount till date. Okay, but that really does not add any value to the business if you just give them an aggregate sum total, right? So this is where dimensions come in, and dimensions are used to add context to your facts. This is a fact or a measure, right? And you add dimensions. You add dimensions either across the x-axis or across the y-axis or across the z-axis or across any axis, okay, to add context to that fact. And you can just think about it from a very, you can think about it. If I explain this to you, just taking a cube, okay, you just think about it. This is your just a cube. If you take a particular sales amount, if you take a particular sales amount, that sales amount is a big number, right? Now you can actually break this sales amount, and sorry, let me take a new one here. You can actually break the sales amount based on color And then what will happen is each color, let's say these are each colors: red, green, blue, yellow, orange, brown, purple, and so on. Okay. Now each color will have its own sales amount value, right? So now the sales amount will become aggregated over each color. So it's just like writing a select query where you're doing group by color and sum of sales amount. So essentially, that one big value is now broken down across multiple smaller values, and it is broken down across a dimension of color. So I'll call this EOL color. Okay, and which is exactly what I'm doing here. So I can take that color here, place it in columns. Now you can see I've broken that value. I've broken that aggregated sum value of that big value, that grand total that you had of 2935867 into multiple smaller values across that dimension of color. Make sense? That's the excellent quality of a dimension. Okay. Now what I can also do is I can further break it up. I can further break up this value. I can further break up this value across another dimension. Okay, and you might want to take something like a size. Okay, might want to take something like a size in the rows, and you can see that you have broken it down based on the size. Okay, so what is the dimension doing? The dimension is not really measuring anything. The dimension is adding context to something that you're already measuring. So it is using to break down that particular value, and it is allowing you to add context. Okay, so and just to also give you an example, and this is where the queries can get really analytical. What were the total sales between size 38 and 48 for the colors black and blue? Okay, and this is where you can actually start asking some very good questions. So you can see black and blue. What were the sum of sales for size 38 to 48 for black and blue? And you can see the sum of sales is 77 to 398 on 8%. This would not have been possible if you did not have dimensions. Okay, it is only because of dimensions that you're able to break it down into queries. Okay, right? It's the concept of dimensions here. So it is purely adding context. So you can take size, you can add n number of dimensions. So size, will be go and remove size. Go back to my back table. See, time is my big product here. Might want to take category also. A category. Might want to take something for category name. And I can see for accessories, bikes, what's happening. And now what you can do is you can add one more. You can add one more dimension, and this time I'm going to take it across. See if I put in date. This time I'm going to take it across the date, right? And you can see that the level of detail I've been able to add here. Okay, so this is really amazing, the level of detail I can add. So I've already broken it down by colors, color dimension in the x-axis. You can just think of it as an x-axis. I've broken it down by the product name and the category name, product category name, and the year, essentially the due date. Due date can further be broken down into year. Just expand 2013, you will get quarters. You expand quarters, you get semester, 8 months, and essentially semester is not there, but you can still put, and you can see individual days. So this is the level of detail that dimensions are adding. Okay, and across every step, you can see that the one that comes in bold is what is summed up. Okay, you can see that now. You can see that big number, that initial big number that I had, sum of sales of 293,58677 is still there. If you add up everything from here, you add up everything from here, you still get that number. And it need not always be an addition, right? It can be literally anything. You can either take, you can even take an average. Okay, essentially it really depends on what the aggregation is. Alright, so now what is happening is this is a complete aggregate, and this time the aggregate is the average. Very simple way to change it, value field settings, and you can change the thing. Okay, that's just an analogy that I'm giving you. Okay, and essentially this is a total aggregate, and you can break this further across multiple dimensions. Alright, so that's about facts and dimensions. So facts are the numbers that you will identify, and dimensions are really on what basis you want to analyze those uh, metrics. Okay, so the obvious question is that how do I analyze it? It again, as I said, really depends on, because if you are designing a data warehouse, you will always design a data warehouse thinking of the reporting in mind, because that is a fundamental uh, That is the end product, right? At the end of the day, you want to deliver good quality analytical reporting from your data warehouse. That's the end result. So whenever you develop a data warehouse, you should always have the end reporting in mind. You need to ensure that, okay, so this is how I'm going to do reporting later on. These are the kind of queries I'm going to write. And okay, so for this is the kind of data I need. So if you know that management wants to know sales information across date, across color, across product category, across zip code, across phone number, that is how those are the dimensions you're going to take. If management wants to, okay, so let's say you're not right now build a data warehouse, but tomorrow the management says, all right, so you know what, I really want to know what were the sales across different gender groups. So it's a new requirement by the management, but if you go back here, you can see that I don't have anything on gender. So you can see dim product, category, subcategory, but I have not really broken it down by gender. Although I have a customer key, although I can link it to the dim customer table, we know that the dim customer table has a gender, but then I have not included it in my data warehouse. So in my current data warehouse that I built, I simply have one fact table, and that fact table has a list of all my measures, but and three-dimension tables, and none of those dimension tables have the gender attribute. So I really cannot break it down by gender attribute. Okay, so I will not be placed to answer that question because I don't have that data captured. So it's very important to have the end result in mind, the end goal in mind, where you're going, what kind of questions that data warehouse has to answer, and it is based on that you finally go back and build something. Okay, so what is the fact table? So far we have been talking about, we've talked about the fact and thread sales table, the dim customer table, the dim product table. Let me quickly go back and show you what these tables are. I know we have already discussed this, but I just wanted to give you a quick review of some of these concepts. Connected. For databases. And first thing that I want to show you is the fact table. I did tell you that what are facts. Facts are basically nothing but these are metrics. These are different metrics that you have. They're either called facts or they're called measures. These are the metrics, and a collection of facts is how you form a fact table. Okay, if you come to a fact table, an example of a fact table is fact and thread sales, and you can see this is how we form a fact table. Okay, you can see that they have a list of all the different metrics that you can capture. Okay, you have tax amount, you have sales amount, you have freight, your product cost, you have standard cost, discount amount. These are all the different metrics that have been identified. So business might want to know anything. Business might want to know average unit price. They might want to know total sales. They might want to know total tax. They might want to know average freight. So all these things, even product cost, you might want to know the total product cost aggregated across. So they can average standard product standard cost. So all these things aggregated across is what you're capturing in your fact table. Okay, one more very important property. Okay, I'll come to that. So this is what you basically have. Roughly in a fact table, you have a collection of all facts, right? So you can sit with your business, identify your metrics, and based on that, you will arrive at your fact table. You will have a rough idea. Okay, what all metrics or what all facts you need to include in your fact table. And after that, you have the dimension table. And here I was analyzing the certain product category table, and this is where if you come here, you should be able to see a dimension table. Right click, go to product category, and you can immediately see what the dimension table contains. Dimension table basically contains attributes. So it's your product name, category, French name. And these are basically what we call attributes of a dimension. Okay. In fact tables, you have facts or measures, which are individual columns, and a dimension table, these are called attributes. Okay. In fact tables, you have foreign keys. You have foreign keys. Where were the foreign keys? You can see these are the foreign keys. Okay, why is it a foreign key? Because say product key 310, product key 310. So essentially, it's a combination of multiple key columns that forms a composite key. Right? You don't really have a primary key in a fact table. I've queried the fact table here. You don't really have a primary key. So it's a collection of foreign keys, which we call a composite key. That's how you form a composite primary key. Okay. So that's how you determine uniqueness in a fact table. There's no concept of primary key here. Okay, make sense? Yep. So these are the foreign keys, and these foreign keys link back If you look at the product key here, the product key here will link back to the dim product table. This is the dim product table that you have here. And you can see the product key mentioned here. And this is what we have, the primary. The dimension table, your primary keys, and the fact table, your foreign keys. Okay, so the primary key, which means that each product, you can see that particular product 310. 310 was that particular product ID that we are looking at that time. And you can see that for 310, these are the attributes of 310. Okay, why is this important? It is very, very important because if we talk about relationships, and this is how you define relationships between facts and dimensions. Facts always contain foreign keys to your dimension tables, and dimension tables contain the primary keys. Okay, yep. Now, one question that I really want to answer is basically, if you look at attributes, you can see there's so many different attributes that I've included. And there's no real easy answer to this question. I mean, it really depends on your requirements. As I said, that for dim customer, you might have dim customer, and the management might want to know that, okay, so what were the total sales by gender. So although you have built the dim customer table, although you have ideated that, okay, I need something called a dim customer table where I will show the gender, but for some reason you don't take the gender column. Okay, and another very, very important consideration while you select attributes is, can you capture that data? Okay, and it's very important, right? So essentially, it's like saying if you're collecting data, right? I mean, essentially, how will you get this information? The information has to be collected from for each customer, right? So there could be things like branch occupation, or there could be things like simple example can be address line 2, simple instances where you may not get data. Okay, if you don't get data, you have to be very, very mindful whether you want to keep those columns in a dimension or not. There might be instances where you cannot collect data. So for instance, English occupation. I mean, people may not want to share their occupation details with you. Okay, in those sort of scenarios, that you will not have that data. Okay, so although there will be scenarios, so management will basically want to query based on everything. That's the ideal scenario, but you have to be also mindful of the fact whether you can get that data, because if you don't have data, the queries will make no sense. Okay, because you will have more than half null values, which is something we have here. Okay, so you have to be mindful about that also during the data warehouse design. There's another important concept that I wanted to cover is the concept where you have multiple packs here. Of course, the fact table, you have multiple packs and you have multiple key columns. And I hope you have understood this part where it is linking back. So it's a combination of product key, order date key, due date key, ship date key, customer key, promotion key, currency, subscriptory key. So it's a combination of these 8 columns that forms each record of a fact table, of this particular fact table. Okay. You do have a particular field called sales order number. I'll come to this particular thing later. You might be wondering, what is this? Is it a key column? Answer is no, it is not a key column. In fact, we call this a degenerate dimension. I'll talk about it in a while. But before that, as I said, I just wanted to cover this particular section where I'm saying that this combination of keys form one fact table. This is what we call granularity of that fact table. Okay, very, very important concept. This is what we call granularity of the fact table. And please remember that a combination of all these foreign keys basically determine the uniqueness of each record in a fact table. Okay, you might still have a scenario where the first seven values are same for both two rows, but then the eighth value will be different. You might still have a scenario like that. Okay, so be very, very mindful of that particular fact that you can have basically that determines the granularity of your data. And if you think about it again from an analogy point of view, fact table data is nothing but transactional data. It's detailed level data. And granularity, as I've already discussed before, granularity, the term means the level of detail. Okay, more granular your data, more the level of detail. So the more granular your data, the more level of detail is there in your data. So essentially, you need to. So in this case, you can see I'm breaking it by dates. Okay, which is really a very high level of granularity, very high level of detail. If you want, you can skip the dates altogether. It really depends on what level of detail you want to capture your data. And the reason why I have dates here is because I know that management will want to answer, ask these kind of questions. Okay, so um, what are the total sales for the past months? Okay, so the other point that I wanted to cover here is what if management wants to know, given that you have a fact table, like this, what if management wants to know hourly information? What if I ask you a question, what is the total sum of sales from, how has the sales performed from in the afternoons, let's say from 12 afternoon to 5 o'clock, or 12 to 4, let's say 1 to 4, 1 to 4 in the afternoon, how has the sales been? Can you answer that question? Answer is no. Let's say, how have the sales been for females in the afternoon, 1 to 4 o'clock? Can you answer that question from this fact table? Answer is no, because you're not storing time information. Okay. See that my granularity is only restricted to date level. It is not up to time level. It is not up to hour level. It is not up to minute level or second level. So I cannot answer that kind of question. So you need to be very, very mindful of the fact as to what level of detail your data is stored in. Okay. Yeah, makes sense. So this is what we have from the fact table point of view. And as I was saying, that if you come to a different fact table, and basically these are all the measures that you've grouped in, and you can have multiple measures in the fact table. Okay, so you will identify your measures, and you will group multiple measures in one kind of fact table. This is fact and trade sales, where you have all these measures grouped in, because they are capturing data in the same level of granularity. And this is what your level of granularity is, the combination of your parameters. That is how we are defining your granularity. Okay, makes sense. So that's basically the reason why you have listed down all these measures in a single fact table. If I go back and show you one more fact table, if you take any fact table, let's say fact call center, the call center data is coming in. So you can see that here it's completely different kind of data that's here. Okay, it's a different kind of fact table that you have here. Okay, and here you can see the categorization is based only on fact call center ID and date key. Okay, it is just based on fact call center ID and date key. And what is this fact call center ID? Yeah, so that's basically what I have. It's just based on date key. So for each day, what are the data captured? Okay, it really depends on your level of granularity. And similarly, you can have other fact tables such as fact finance, you have fact reseller sales. Just have to go back and show you fact reseller sales. You see that again here, it's slightly different. You have product key, order date, due date, ship date, which sounds pretty similar, but then you have something called reseller. You have employee key, you have promotion key, which was not there before. So employee key was not there before. So you have some additional columns that are induced. So here, again, the granularity is a little different. Again, if you come to something like a fact product inventory, you'll see that here the granularity is again different. Granularity here is more like product and date. Okay, it is product, date, and movement. So combination of these three key columns basically forms your level of granularity. Okay, so it really depends on what your level of detail is at which you can capture your data, and it is based on that you will capture facts in separate fact tables. If the level of granularity is the same, for instance, you will identify your metrics, and if you know that the level of granularity for these metrics are all the same, in which case we put them in the same fact table, else you will put them in different fact tables. Okay, but the idea is similar. Fact tables will contain foreign keys, dimension tables will contain primary keys. All right, so coming to the concept of degenerate dimension, just a while back I showed you the fact and trade sales table. This is something you will find quite often. And before that, let me also show you one other instance that I saw here. You will often find things like this, fact call center ID, and here you can see it's a separate ID that the fact table has. Okay, it's a rarity. Fact tables typically don't come with a primary key, but there could be instances where a fact table has its own categorization of keys. You can have it, and this is again typically used where you are trying to link fact to fact. Okay, so this is something that I just wanted to highlight. So this just count the number of rows. So you see the number is very similar to the row number. So each row is identified by a unique ID. Okay. Coming to fact and trade sales again. So as I was mentioning, that these are all the foreign keys. But if you come to here, something like a sales order number, you'll be wondering, what is it? fact table can either contain a foreign key, or fact table will contain a measure or a metric that you can actually add, subtract, do some aggregates on. Okay, but when you look at the sales order number, it is nothing, right? So the first thing that comes to your mind is, okay, what is it? Is it a key column? Is it a metric? And the answer is, it is none. Okay, so it is neither a foreign key nor is it a metric. So this is what we call a degenerate dimension. Okay, so you can think of it as saying that, as if you have a separate table, as if you have a separate table for sales order number, as if you have a separate dimension table for sales order number. You go back and put this table here. Then you can see that there are all the values of the table. And let me say that ID comma name. The IDs are S043697, S043697, and so on and so forth. So these are the different values, and probably will have some name and some other attributes related to that. Okay, some other details about that line number say. Okay, so the idea here is that instead of maintaining a separate table for that purpose, you're essentially storing all that data in the fact table itself. Okay, and what is the reason? Is it, first of all, is it good practice? Because the question that will come to your mind is, all right, if I can store fact table, if I can store dimension data in the fact table itself without maintaining primary key, without maintaining the primary key foreign key relationship, you will argue that, all right, so for customer key, why do I need to have a foreign key here? Why can't I just have all the first name, middle name, last name, everything coming together? I can absolutely have it right. We are right, you can do that. Promotion key also, you can further denormalize the table. And what do we call that? Right now, these are broken down into smaller tables, right? Because it's a fact table. If you look at the broad schema looks something like this. You have the fact table here, you have the fact table here, and you have the dimension tables around it. You have the D's around it. This is one dimension table, this is one dimension table, this is one dimension table, this is one dimension table. So essentially what you have done is you have broken down, and you have kind of you have one big table, and you have broken them down to smaller tables. So what if you're saying that you want to get rid of customer and you want to put customer information in the same fact table, essentially what you're saying is, I want to get rid of this table, I want to get rid of this table, and I want to have all this data inside of the fact. I want to get rid of this table, have all the information inside this fact. That's what we're saying. And basically what this means is denormalization, right? We are doing denormalization, which is good, which is absolutely beneficial, but you need to make sure that it really is going to put a huge amount of load on your fact table, because you can see that the amount of duplication that's going to happen here. Okay, the amount of duplication that's going to happen is immense, because you're storing data at an aggregate level of date, and you can have a huge amount of duplication if you're especially if your customer table has 10, 15 attributes. It's a very, very bad practice to have dimension attributes in a fact table. This is an exception. This is an exception. The reason is because you have only one attribute. So even if I create a separate dimension table, I will have an ID, but then the name is basically this, and the ID will probably be 1, ID will be 2, and the name will probably be 6, 9, 8. So this is how data is going to look like. So you might argue that, okay, so instead of having sales on a number, why don't I have sales on a number ID 1, 2, 3, 4, 5, and so on, and link it to the dimension table where you have the ID and names defined. Well, absolutely correct. You can do that. But the problem is that it has a huge amount of it has a huge cardinality. We call it cardinality. Okay, and what is cardinality? Cardinality again is a very database centric concept. So let me go back and quickly open the new window and show you. So cardinality in this case is like saying fact table. In the fact table you have, and let me just go back and show it like this. So how many records do you think this has? How many unique records do you think this has? Let's assume it has. Let me just put the fact table here. That's a fact table, right? And let's say this is a dimension table. And let's say if you have something like a product category, dim product category has just 4 rows, right? Strictly dim product category just has 4 rows. So it just has 4 rows here, and you're mapping these 4 rows to, like, I'm just giving an example, let's say 4,000 rows in a fact table. You just imagine the level of cardinality here. The level of cardinality is very, very low. The level of cardinality is how we calculate as 4 is to 4,000. So we say it is 4 is to 4,000. That's 4 by 4,000, which is 1 by 1,000. That's your level of cardinality. Okay, it's the ratio sign. Sorry, my writing is not. Okay, so the cardinality is 4 is to 4,000. So essentially there are 4,000 entries. So for 4,000 entries, there'll be 4,000 foreign keys, but there are only 4 primary key rows. Okay, makes sense? Yeah. So the cardinality is 4 is to 4,000. But in this kind of a scenario, why do I call it high cardinality? I'll come back to internet sales again. Why do I call that sales order number as high cardinality? Because you can see there's so many unique values that they're all. It's almost like saying that they're all unique values. Okay, they're all unique values, right? And if I have to just quickly show you the number of results, you can see if you start to quickly do a count chart and show you this total number of rows in this particular table is 60,398. However, I just do a distinct of this. You'll see that I just do a distinct of this. You can see that you have close to. You see that you have close to those here. Okay. You can. Let me see. Okay, I think I've done a sales order line number. I'm sorry, let me put a sales order number. And if you do a distinct of this, you see 27,659 rows. So it's like saying that 27,659. So the fact table has close to let's say 66,000 rows. Let's say the fact table has close to 66,000 rows. The paint is not working. I'll take an Excel and type it out there. Okay, so like saying the fact table has close to 66,000 rows. Dimension. If your dimension is in product category, your dimension has only 4 rows. Okay. In case of English product category, your dimension has only 4 rows. In which case, the cardinality is 4 is. Okay. However, in the other case, in the case of sales order number, what you have is again the fact table has 66,000 rows. For essentially, it means that there are 66,000 foreign keys. But then, how many primary keys will you have if you had a separate dimension? If you had to maintain this as a separate dimension, you have so many unique values, which means you have roughly 27,000. You're roughly 27,659 unique values, and you can see the cardinality is so high right now. Okay, you can see the cardinality is so high. Okay, yeah, makes sense. So it is because of this reason. It is because the cardinality is so high that if you maintain it as a separate dimension, you have to. I mean, the dimension itself will take 1/3 or more than 1/3, almost half the space as a fact table, which is very high. So you won't create a separate dimension. It is as good as storing that in the fact table itself, which is the same reason why we have stored this data in the fact table itself. And the other reason is because it really does not. I don't keep things other attributes. Unlike customer, where I'm going to have the first name, middle name, last name. It's like even if you replace customer key, you have to include multiple attribute columns. But in this case, it's just a matter of including a single column. Okay, so you don't really need additional columns. Just have ID and name. You don't really have other information. That's one of the other reasons why you include it here. That's what we call a key generate dimension.
I'm sure you enjoyed learning from this video. Please like the video, and if you have any doubts regarding this video, please comment us in the comment section, and don't forget to subscribe to our channel for more such informative videos. Do look out for other related videos in our playlist. For more information, visit our website now. Keep learning with Intellipaat.